This video is over lessons 66 through 68, lesson 66, multiplying mixed numbers, and lesson 67, using prime factorization to reduce fractions, and lesson 68, dividing mixed numbers. Take a moment to copy this title down into your notes. When you're ready, continue. Moving on in 3, 2, 1. When multiplying mixed numbers, many students make a very big error early on. For example, if we had 6 1/4 and multiply that by 5 2/3, early on, most students would say, well, 6 times 5 is 30, 1 times 2 is 2, and 4 times 3 is 12. This is wrong. It'd be convenient if it was just this easy, but unfortunately, it's not. So the big question then is, how do we multiply mixed numbers? And the answer is quite simple. You don't. You don't. There is a way. It's actually quite complicated. I could explain it in class, but it's just really not worth going over. So instead, we've got to do something else, because we still need to find an answer to this. So if we don't know how to multiply mixed numbers, that means we need to take our problem and change it into something that we do know how to multiply. Well, I may not know how to multiply mixed numbers, but we do know how to multiply fractions. So if I can change both of these into a fraction, then I can multiply them together. So we need to remember from a previous lesson our formula. So if I have a mixed number, which is made up of a whole number and a denominator and a numerator, that this equals the whole number times the denominator plus the numerator all over the denominator. So that's my formula for changing a mixed number into an improper fraction. Also remember that it kind of follows this U shape. So we've got the whole number times the denominator plus the numerator. So here we go. Back to my mixed numbers then. So 6 times 4 is 24, plus 1 is 25. So this becomes 25 over 4 times 5 times 3 is 15, plus 2 is 17 over 3. And now we're ready to multiply. 25 times 17, chances are we're going to need to do a little scratch work there. So down here we'll do 25 times 17. 7 times 5 is 35, carry the 3. 7 times 2 is 14, plus 3 is 17. Put a 0 down as a placeholder. And, well, 1 times anything is itself. So that means I have a 5 and a 2. Add it all up. 5 and 0 is 5. 7 and 5 is 12. Carry the 1. 1 and 1 plus 2 is 4. So this becomes 425 over, well, 4 times 3 is 12. To finish this off, we remember that fractions mean division, so a little bit more scratch work to find my final answer. So 12 goes into 425. Well, 12 does not go into 4, but it goes into 42 3 times, which is 36. 42 minus 36, well, if you remember your multiples of 6, 42 is 6 times 7. 36 is 6 times 6, so there's one group of 6 difference there. So the difference must be 6. Bring down my 5. 12 goes into 60 5 times. 5 times 12 is 60. And we subtract and we have a 5 left over. Remember, your remainder becomes your numerator, and whatever was the denominator still is the denominator. So bring that up now to my work. My answer is 35 and 5/12. So once again, to recap, do not just multiply the whole numbers and the fractions. In order to multiply mixed numbers, you have to change both of them into improper fractions and then simplify. Moving on in 3, 2, 1. Like multiplying mixed numbers, we don't divide mixed numbers. We just don't do it. So let's go back to our numbers from before. 6 and 1/4, but this time we're going to divide it by 5 2/3. So just like before, we are not going to actually divide these. We're going to turn them into something that we do know how to divide. And we do know how to divide fractions. So once again, I'm going to change these into improper fractions. So 6 times 4 is 24, plus 1 was 25. So this becomes 25 over 4 divided by, and then 5 times 3 was 15, plus 2 is 17, so 17/3. Now to divide fractions, hopefully we remember that dividing by a number is the same as multiplying by its reciprocal. So dividing by 17/3 is the same as taking 25/4 and multiplying by the reciprocal of 17/3, which will be times 3/17. And if we multiply 3 times 25, we should have memorized as 75. And then 4 times 17, well, 4 groups of 15 is 60, which we know because of the clock, and this is 2 groups more. So it must be 68. Do a little bit of simplification here. So we need to do 75 divided by 68, which we know that'll go in once. And if we subtract, so borrow from the 7, that becomes a 6. That becomes 15. 15 minus 8 is 7. And 6 minus 6 is nothing. So my remainder becomes my numerator, and whatever was the denominator still is. So the answer is 1 and 7/68. So whether it's multiplying mixed numbers or dividing mixed numbers, we always change them into improper fractions first. Moving on in 3, 2, 1. We can use prime factorization to help us reduce fractions. For example, let's take a look at 28 over 42. So first we need to find the prime factorization of each of these numbers. So for 28, let's find its prime factorization using division by primes. So if I divide by primes, we're going to use the upside down division box. And I know that 2 is prime, and 2 goes into 28, and it goes in 14 times. 14 is not prime, so we need to divide again. Well, 2 works again. 2 goes into 14 7 times, but then 7 is a prime number, so we're done. So put it all in order. The prime factorization of 28 is 2 times 2 times 7, which I'm not going to circle because I'm not done with the problem. That's not my final answer. Now I need the prime factorization of 42. This time let's do a factor tree. So I know that 42 is 6 times 7. 6 is not prime, so that means I can branch off more. I can branch off into 2 and 3. 2 is prime, so that branch is done. 3 is prime, so that branch is done. For that matter, 7 is also prime, so that branch is done. So the prime factorization of 42, put it all in order, is 2 times 3 times 7. Now that we have the prime factorization of each number, we can use it to help reduce the fractions. So I'm going to come back up here and I'm going to replace each number with its prime factorization. So I'm going to replace 28 with 2 times 2 times 7, and replace 42 with 2 times 3 times 7. Now, just as we've learned before, we can reduce before multiplying if we have something on top that can reduce with something on bottom. Well, obviously, a 2 can reduce with itself. And when a number reduces with itself, they both become 1s. And then a 7 can reduce with itself, which means they both become 1s. And I'm all out of options. So now if we multiply what's left over, well, 1 times 2 times 1 is 2 over 1 times 3 times 1 is 3. So my reduced fraction is 2/3. This video ends in 3, 2, 1.